When Michio Kaku took the stage to give his most recent speech, the tension in the room was almost palpable. The renowned theoretical physicist, famous for his in-depth research into the secrets of the universe, did not waste any time before unleashing a remark that sucked the air out of the room. The moon that we have long known could be something else entirely. This was not a poetic reflection or a hypothetical aside. It was made with the assurance of a person who is poised on the brink of an important scientific revolution. For years, the moon had been presented in textbooks and documentaries as a barren satellite, a cosmic accident forged in the universe with our planet as it dances eternally in space. And here was Kaku indicating that the very presuppositions upon which that exists may be false. Before we begin, hit the like and subscribe buttons for more information. He started out following the traditional account, the commonly accepted giant impact hypothesis in which a Mars-sized object struck Earth billions of years ago, hurling material into space where it ultimately formed the moon. Although the hypothesis has been persuasive, fitting much of observed evidence, Kaku noted that recent measurements, spaceborne observations, and seismic data from previous lunar missions have begun to uncover discrepancies too large to overlook. The density of the moon, its peculiar distribution of some isotopes, and the uncharacteristically accurate nature of its orbit were only the start of the inconsistencies. These hints, he claimed, have for centuries been ignored or minimized because they didn't comfortably fit existing paradigms. The mass of the moon is peculiarly light for a body of its proportions, having less density than might be supposed. This in itself would not be sufficient to trigger suspicion, but when coupled with its unusual minimal makeup, the enigma deepens. Returns from samples taken during the Apollo missions were isotopic ratios uncannily akin to Earth's, much more so than should be the case if the moon did form from a wholly distinct planetary body. Although the giant impact hypothesis can explain some of this similarity, the precise matching of some of the oxygen isotopes is a mystery. It is as if the Earth and Moon were created from the very same batch of cosmic material in circumstances more precisely controlled than random chance would permit. He then turned his attention to structural and seismic data, returning to the astonishing findings of instruments left on the Moon many years ago. Part of these experiments intended to detect lunar quakes indicated that the Moon rang like a bell when hit by meteor strikes or when spacecraft stages were intentionally crashed onto its surface. This ringing implied an extraordinary internal structure that does not conform to simple models of a homogeneous rock sphere. Although this ringing doesn't literally translate as the moon being hollow, it does pose deeply interesting questions about what's inside it. Kaku pointed out that some of the layers in the moon are surprisingly consistent in their thickness, almost as if engineered looking, and that such accuracy in a natural satellite is very uncommon. Another remarkable point he brought forward involved the moon's orbit. The moon's distance from Earth, its perfect angular size relative to the sun during eclipses, and its locked rotation, always showing us the same face, have long fascinated astronomers and casual observers alike. While these features can be explained through tidal locking and orbital mechanics, Kaku emphasized the improbability of the combination of factors aligning so perfectly. This, he contended, could be a cosmic coincidence or a sign that the history of the moon is stranger than we have been willing to believe. He interwove the meaning of new data obtained from recent lunar probes, which have discovered anomalous concentrations of particular metals just under the surface, some of which are not found naturally on most planetary crusts in large abundance. These metals were discovered in areas as deep as they could not possibly be deposited by meteorite impacts, with radar readings showing void-like cavities under the crust. The results suggested processes or events involved in the creation of the moon that are not predicted by existing models. Kaku then also broached ancient accounts and myths not as evidence themselves but as cultural items of interest. Among civilizations from Sumerian writings to Native American folklore, there is a narrative that describes the time prior to when the moon was suspended in the sky. Although such stories are always written off as allegory or metaphor, the sheer frequency of the motif fascinated him. He never suggested these myths were demonstrative proof. But the fact that they were so consistent on different continents implied that human history with the moon may be more extensive and weirder than we now accept. From this point on, the conversation became almost movie-like as Kaku explained the possible explanations for these enigmas. One of them entailed a much more complicated initial history of the Earth-Moon system with several giant impacts and shuffling of planetary material over geological timescales. Another possibility considered was that the formation of the Moon was governed by forces or events yet to be discovered. Maybe events that tested the boundaries of current physics. He even suggested in the most radical interpretations that some scientists have flirted with the idea of the Moon somehow artificially transformed in deep time, not by any historical civilization, but potentially by processes or intelligences not within present human understanding. The stakes of such disclosures are enormous. If the formation of the Moon cannot be squeezed into naturalistic accounts as we know them, it may indicate that our theories of planetary formation are partial or fundamentally incorrect. It may also change the way we read back the history of the early solar system, potentially uncovering a missing chapter in the form of cosmic-scale processes that influenced not just our planet, but the conditions for life itself. The Moon's significance in maintaining Earth's tilt, its control of tides, and possibly supporting life would make any new insight into its existence all the more important. Kaku discussed at great length how technology now makes it possible for us to investigate these enigmas deeper than ever before. High-resolution mapping of the Moon, gravitational field measurement, and powerful spectroscopy are providing scientists with unprecedented information about the Moon's structure and geology. Every new piece of information is a brushstroke on an even bigger, more complex canvas, one that could be painting a Moon with a much more mysterious identity. He emphasized that these scientific mysteries are not mere intellectual curiosities. The Moon is at the center of humanity's destiny in space. Lunar base plans, mining, and employing the Moon as a staging ground for further exploration all rely on knowing its character. Should its internal structure or history harbor surprises, these endeavors may be impacted both negatively and positively. As an example, if there are rare metals in large quantities under the surface, they might revolutionize space industry. On the other hand, if its composition is more unstable and involved than we assume, that might raise engineering and safety issues for colonization in the future. While Kaku was speaking, his audience leaned forward, attracted not just by the science but by the grand sense of wonder still surrounding the Moon. He reminded us that humanity has looked upon that silver disk for thousands of years, composing poetry, dating calendars, and revering it as a presence of the divine, and that even now with all our machinery, we may hardly comprehend it. The Moon, he proposed, is not merely a cold, lifeless ball of dust and stone, but perhaps a door to understanding the secrets of the universe itself. He explained the way missions from other countries, including China's Chang'e mission and future NASA Artemis missions, will soon supplement with more important data. These missions are intended to drill deeper, chart uncharted areas such as the lunar South Pole, and hunt for water ice deposits that would sustain human life. But aside from the practical purposes, these flights would also expose hidden anomalies deep within the crust, anomalies that would perhaps compel the scientific community to rethink the Moon's real tale. Until now, the Moon continues to be a paradox, familiar yet foreign. Its light has led our forefathers in the night, its force has designed our seas, and its cycles have given rise to myth and science as well. But if Michio Kaku is correct, what we believe we have learned is merely the tip of an infinitely stranger reality. He ended his lecture with a statement that brought the room into silence. Perhaps the biggest enigma is not where the Moon originated, but why it appears so immaculately placed to fulfill its part in the tale of life on Earth. Was it fate, or was it luck? The crowd applauded, not for the answers given, but for the questions honed. In the years to come, when man goes back to the Moon with new vision and fine-tuned tools, we shall perhaps start to unravel the enigma at last. Meanwhile, the Moon will remain above us, venerable and still, holding its secrets out of our grasp, challenging us to pose questions we once believed we had answered.